Okay, here's a little video that shows how we connect some of the things that we're doing with this theme of Islam and mathematics with some of the things that we teach in elementary algebra, intermediate algebra, or maybe even college algebra. So here's how it looks when we do that. Okay, so remember when we talked about why do we call it algebra, and we answered the question, well, it's because of the first algebra book written by Al-Khwarizmi around the year 800. Well, look what I found here. Problem on completing the square actually right out of Al-Khwarizmi's book. So Al-Khwarizmi has this problem in the book. What is the square which combined with 10 of its roots will give a sum total of 39? Well, when Al-Khwarizmi talks about the square in our notation, it would be x squared. When he talks about the root in our notation, it would be x. So this same problem right here, or question, in our notation looks like this. Solve x squared plus 10x equals 39. So what square, when combined with 10 of its roots, gives a sum total of 39? All right, so here's the solution out of Al-Khwarizmi's book. The manner of solving this type of equation is to take 1/2 the roots just mentioned, so that's 1/2 of 10. Now the roots in this problem before us are 10, therefore take 5, which multiplied by itself gives 25. Okay, so Al-Khwarizmi takes half the coefficient of the linear term right here, squares it, and an amount which we add to 39, giving us a sum total of 64. Having then taken the square root of this, which is 8, subtract from it half the roots, 5, leaving 3. The number 3, therefore, represents one of the roots of this square. Okay, so that's Al-Khwarizmi's solution to this problem. Here is what it looks like in our notation. X squared plus 10x equals 39. Take half the coefficient of 10, which is 5, square it, which is 25, add it to both sides. This becomes the perfect square, x plus 5 squared. The right side is 64. That means that x plus 5 squared equals 64 implies that x plus 5 is 8 or x plus 5 is negative 8. So we get 3 or negative 13. So Al-Khwarizmi is talking about this root right here, 3. Now, what's interesting about this to me is that all of Al-Khwarizmi's book is written in paragraph form like this. You have to understand that the equal sign isn't invented for hundreds of years. He doesn't have this notation to work with like we do. So it points out a couple of things. One is the tremendous amount of concentration it must have taken to do mathematics at the time Al-Khwarizmi wrote that book, because everything's in paragraph form. There is no symbols or equal signs or things like that to work with. The second thing is how nice our notation is, how compact and concise, and all the information that's contained in it. It actually makes it easier for us to reason our way through problems like this. So the other thing I think that this gives us is a connection with Al-Khwarizmi himself. So here we are in an algebra class in the United States, taking algebra, learning how to solve quadratic equations by completing the square, and we go back and solve a problem written by Al-Khwarizmi, and we can see in his own words here how that translates into what we do. So it gives us kind of a bond with him that travels through time. We know exactly what he was doing in that book. We're solving the same type of equation.